film.
Alright, so this piece right here will be flowing water in a linear form. What they'll be doing is filling up a canister that's attached to a counterweight on this shaft, which is spring-loaded in here. That will until turn these gears, and the gears will then have this piece up here that will actually be water troughs that will be rolling down constantly, smaller than what you see here though, scale to size. That will be kind of a conveyor. And as the water's coming here and the counterweight's coming off of this piece here, it'd be moving these pieces slowly up and down as they're filling with water the whole time. They're filling with water because they're basically going to be dunking in, coming back up with it. And as they come up, they're going to pass this gear and counter shift. Let it move and catch up. What's happening with this back again? So the rod with the water coming down will be working in tangent with these pieces here, letting it flow without any other movement. It'll just be the water weight working it all together.
So the water's driving it.
Yeah, the water will drive everything.
Yeah. Where does the water first enters through the rods?
These pieces right here.
That's where the water's coming into the system.
It will actually pick up water from down at the bottom trough.
Yeah. And
it'll come out with the water in it. And as they go up, they will. Let's see if we can match it. See if it'll move. But you can't really see. Well, it will attach to a piece that's on this gear. And as it goes up, they're constantly going to be moving it, and this is on a spring, so the spring loads up with tension and water weight on the other side.
Yeah.
Then it'll push it down. That will then make these things, it'll kind of jolt these
and
have them stop the other way, and then the water weight will keep it moving. So you'll have movement up and then movement back down to it. As these pieces here, as these pieces here are running in a loop, and they come back up filled with water and their water weight, they're going to be run by this gear, a separate pinion gear that's continually running this off of the weight here and spring loaded. Depending on how it needs to work in tangent and the weight and the mechanics of it, I might add a DC stepper motor to the back of that gear, and that will basically start it up and get it going, and then the water weight should carry it along. If the water weight doesn't carry it along, it'll be a continuous running small stepper motor. You won't hear it, it won't do anything. It'll still give the appearance of total kinetic, but where it really can't be done, but it'll have the appearance of being done. Okay. So everything will be driven correct. Water will run through it. Water will do everything and have the appearance of doing everything, but a small stepper motor might be what gets it over the edge and lets it do it.
Right. Otherwise, it'd be a perpetual motion machine.
Yeah. Which then we would get on the news and
Nobel Prize.
Yeah, create energy.
Cool.
Yeah. So that's it, you know, and whatever else they might want, or ideas or anything like that, you can figure anything out like that.
Okay.
Yeah.
Okay, cool. So these gears, there's links. I mean, there's some of the links that aren't shown. I assume there's like a link here that's not shown. There's a link here that's not shown. They're connecting, and there's links down the other side.
Yeah, it'd be double linked.
It's like a bicycle chain?
Yeah, it's basically like a bicycle chain. You double link and you'd see all links together, but you're not going to see it right now because it's not letting the memory pull up every single part of it.
Okay.
Just because it's going to be too much for the computer since it's a laptop. But yeah, it would go all the way around.
Go ahead and rotate it around.
Yeah. See, it's not even catching up to it.
Oh yeah, delayed.
Yeah.
You need a mainframe.
Yeah.
So it's a pretty self-contained unit then.
Yeah, it'll all be self-contained.
It's all self-contained. As far as how it fits in the space, it just fits on that wall. The sides, what do you think the sides and the face are as far as a finish?
I would think satin stainless.
Okay.
These would be a satin finish, bronze, fully TIG welded gears.
Yeah.
They're just all custom.
And the back you were thinking is?
I'm thinking stainless or a type of anodized aluminum to have the appearance of magnesium with a piece of glass over it.
Okay.
That way if we light it from the bottom, we could send the light through the glass and it would reflect off the magnesium look, and it'd give a lot of dynamic and depth to it.
Cool.
Do that.
So the magnesium is just a darker...
Yeah, it's basically like a aluminum we take and we dip it, and then that lets it'll give it kind of an anodized brown to kind of an off brown bronze color.
Okay.
Some shine to it.
Sweet.
Yeah. It looked nice.
All right. Good. I'll YouTube it today and let the world know.
Perfect.
All right.